Hello everyone. Today I am going to discuss about the topic under digital electronics, that is the number system. Now, why this number system topic I am going to tell about in at the when you are in the higher grade of studies level. So why definitely some importance are there. So that's why we are going to study the number system again. So before I'm starting this, what the topic I'm going to cover in this lecture, I mentioned here, that is the number, some detail about number, then different kind of number system, then binary number system, a special kind of number system, then conversion between decimal and other number. Now, what is the meaning of number? You know that when we are representing some quantity, suppose number of student, number of mass, number of fish, whatever the quantity. So we need symbols. These symbols and combination of these symbols is called number. Now here you just listen the one word I am using or emphasizing, that is the combination of symbols. So when the whole number is forming with some particular structured manner with combination of these symbols, this is called number system. So now that is the symbols representing a single number is called as digit. That means digit means a single number representing by one symbol. Now number system is what? Number system is nothing but this the some formula, and we are going to discuss about the formula in the next slide, that some applying some formula to making the combination of the digits, and we are getting the sense of the number. Suppose if I am writing a number like in decimal number system, suppose if we are writing like 50. So here is a symbol, one symbol, 0 is another kind of symbols. So when these symbols, now this is 50. If I am writing just opposing, exchange their position, then it's become 0, 5. So both are the same digits are there. Here is 5, here is 0. Here is 0, here is 5. Whether both are same, here we are saying this is 50 and here we are saying this is 5. So when we are framing the number, so it should follow some system. Now this system, according to following this system, we are getting the sense of the number. So what is the meaning? Particular meaning, that if what is the place of the 0? 0 is here or 0 is there. So according to the place, position of the digits in any system, the number is forming. So before going detail, I am going to tell about another main thing, that is base or radix. So what is the meaning of base or radix? That is, in any number system, there are the digits. The number of digits are limited. Suppose in case of decimal number system, how many digits are there? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Using this number of these symbols, we can make any kind of number, any combination. So one point here also, digit is limited, number is unlimited. Okay, so moving to the next slide. Now number formation. Here I have mentioned that number is the various combination of digit according to position. Check. So when we are forming the number, so according to its position, we are getting the forming the framing the number. Now position means what? That is when you have studied from your 10th, that one standard, that is you are using two terms, that is place value and face value. That the number is reside in which house, like one's house, tenth house, 100 house, like this. That is the number is formed. So according to this place, suppose here I am writing a number here like 563. Now if this is what you are saying, 563. Now 563 means what? These three individual digit, here individual digit is called face value. Face value. And that the digit when they are sitting in some room, suppose this is the ones room, this room is the tens house, this room is the 100 house. Okay, so according this 563, if 5 is sitting here, then what is the weight of this face value, place value? Face value is the digit, that is what is the place value? 5 into 100 equals to 500. So when any number is formed, according to its position, it is gaining some value. Now according to this, the number is formed. Now if I am writing here like this, here any number has having two parts, that is integer part and the fraction part. Integer part and fraction part, and the point is called as radix point or base point, or in case of decimal number system we are saying decimal point. Now this is the formation, this is the digit, individual digit according to your position. So first we fix the radix point. From radix point, from the integer portion is the left side one and the fraction portion is the right side one. Now according to this the place is defined. Now it is the lowest integer is just the left of this radix point, and the highest of the fraction part is just right of the point. Now value, when we are calculating the value, so this is the formula. So what we are doing here, now you can see that is individual digit is multiplied by its weight of its place. Where the number is sitting, in that place it is multiplied by individual digit. Then according to this the number is formed. Now when I am going detail, I will show this how the number is forming. So that according to the, now one thing, that is different number system is having different base, like decimal number system, according to the different base or radix, different number system is formed. Decimal number system 10, base is 10. Binary number system by means 2, that is 2. Now octal number system, that is it is having base 8, octal means 8. Then hexadecimal number, that is means 16 base. Let me, I am going in detail about different number system. That you have studied from your childhood, that is 10 symbols are there, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 symbols. So that's why the base or radix is 10, and the value, how the value is calculating. Suppose I am now giving an example. Suppose any number I am writing here 283. Now how the number is forming? This is D0, this is D1, digit 1, digit 0, digit 2. Now the digit is multiplied by its what? The weight. Weight means at this particular position what is the weight of this room. Like this, here this is if base is r equals to 10, then it should be multiplied, that is 0, this is r power 0. Then it should be multiplied by 10 power 1, it should be multiplied by 10 square. Like this, then what is the number, how the number is formed? 2 multiplied by 100 plus D1 value is 8 multiplied by 10 power 1 is 10, and then the next one 10 power 0, that is 1. 3 multiplied by 1. So the total is 200 plus 80 plus 1 plus 3. So this is 283. Okay, now it is clear how the number is forming. Okay, go to other number system. So keep it in mind, when I am the different number system, I am using the term value. So value means every number system, human, we are the human, and the most ancient, from our ancient term, we are using conversant with the decimal number system. We cannot imagine any other thing, human, any other number system. So if I am saying that is in binary, we are using 2 digit 101010. So that doesn't make any sense to our mind. So every time we need to convert in the decimal to get, I mean, to conversion by the human. So when I am going to write the value, that means what is the equivalent of the decimal number. Now here, just now I said binary number system, it is having two symbols. Why? So when the digital number, digital electronics, I am saying that is the binary number system. Binary number system because any digital thing, that is digital means what? Discrete value. So nowadays that we are everything, we are working on the using of the computers or calculator, whatever. So anything when we need to digitize or digital system, we need to convert it in the binary values, that is in the value of 0 and 1 combination. So we designed, or human has have designed one number system that is using only two values, that is using 0 and 1. This is called binary number system, and binary number system is having two only having two digits, so that's why, or two symbols, that's why it's having the radix r equals to 2. Now when the binary digit, one more speciality of binary digit, instead of binary digit we are generally conversant with the term bit. Bit is the small form of binary digit. Now I will explain. Suppose I am writing one value, one binary number, and I am going to calculate what will be the value of it. Suppose here I am writing 1 0 1 1. So this is my D0, this is D1, D2, D3. Now I am going to calculate. So what is the calculation? So every digit is multiplied by its weight. So what is the weight? This is base is 2 and the weight should be calculated as 2 power 0. Here 2 power 1 multiplied by 2 power 2, then multiplied by 2 power 3. So first one is 1, 2 power 3 means what? 8. So what is the value? 8 plus 0 into 2 square, that means 0. Then 1 multiplied by 2 power 1, that is 2. Then 1 multiplies by 2 power 0, that is 1. So what is the value? 8 plus 2 plus 1, that is 11. Now it is clear when I am writing, but only computer or any machine can understand 1011. This is machine language. But when human, what you examine that telling the number to human, you should write the its equivalent value. This is 11. So binary digit. Then I am going to tell about the next other digit also, numbers. Then octal. As I said, that is the, this is digital is only binary is having 0 and 1. 0 and 1 it is taking for simple. You just now you have seen that when I am writing simple 11, it is taking for to represent in binary, it is taking, that is 4 digits. It required 4 digits to represent a small number. So that's why to make more conversion, so what we are taking, that is the simple, this is octal is nothing but the extension of the binary number, but it is having only the 7 values, 8 symbols, and the number it is very much conversant with the binary symbol. We can easily change with the binary number system and octal number system easily, and it is having only base, as it is having 8 symbols, so its rank is 8 and its value is counted like this way. Suppose I am giving one example of this one. Suppose I am writing the, in case of octal, I am writing here a number like here I am going to write octal number, any octal number, like 7, 2 only. Now this is the value of D0, this is the value of D1. If I want to convert this number in decimal, then what will I do? Multiply it by its weight. So weight of this here, radix power, like this. Multiply it here, 8 power 1. Then equivalent number is 7 into 8 plus 2 into 1. 56 plus 2, 58. So in case of octal number 72, we are getting equivalent decimal number is 58. Okay. Then another number system, that is hexadecimal. Hexadecimal number system, it is having the base of 16. 16 symbols are there. So for the 16 symbols, first 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it is like decimal number system, and the rest another 6 digits are A, B, C, D, E and F. Here A stands for what? Equivalent number for A. A equals to 10. B equals to 11. E equals 12. D 13. E 14. F 15. So here the same way we are framing the number. Now I am giving one example. In case of hexadecimal number, I am writing one hexadecimal number, like what I can write here, A5. So this is in hexadecimal number. Its base is 16. What is its equivalent decimal value? What we will do? This is D0, this is D1. Now what will I do? That is 16 power 0 plus A. A means what? Just now I have written. A means 10. 10 multiplied by 16 power 1. So total value in decimal 160 plus 5, that is 165. So when you are writing in hexadecimal A5, then its equivalent decimal number is 165. Now every time I am showing here from different number system, that is what is its equivalent decimal value. Now I am going to show the opposite of this. That is, any decimal number is given, then how we are going to calculate, that is its equivalent, that the suppose binary, what is the equivalent of some decimal number, what is equivalent is binary number. Let me take any number, like any, I am taking any decimal number, like here 45.25. Here, as you can see, here we are, that make difference, we need to calculate in different way, the integer part and the fraction part. First I am going to calculate the integer part. So 45. Now every time you need to divide the number by its base. Binary number system I am going to convert. What is the base of this binary? It is 2. So here we are writing the quotient and here the remainder. So 45 divided by 2, it is 22 and the remainder is 1. Here I am writing 1. Okay. Now again dividing by 2, this is 11 and remainder is 0. Here again dividing by 2, then it's become 5 and remainder 1. Again 2, this is 2 and here remainder is 1, 2, 0, sorry, this is 1 and here it is 0. Now how we are writing the value, like we are starting from here and going to there. So what is equivalent of 45 of decimal in binary, that I am writing here. We are starting from here. This position the called is MSB, most significant bit, and here it is called, the last one is the least significant bit, LSB. So MSB to LSB we are writing here, that is 1 0 1 1, then 0 1, that this portion is gone, that is the equivalent of 45. Now how we are going to calculate the fraction part? To calculate the fraction part, you need to multiply by 2 every time. That is 0.25 multiplied by 2, you check what is the value, 0.50. So unless you are not getting the part after the fraction, you are not getting the all total 0, you need to keep on, that is multiplication. Here that is no value of the integer part is coming. So again you need to multiply here 0.50 into 2. Now you are getting what? 100. So when you are not getting any value, then you should write here, for this you should write here 0. If you are getting the integer value, if you are writing the integer value like here, now after that everything is 0. So here it is start from, this is the after that the MSB after fraction, and this is the LSB. So what is the value total become 0.25 equals to, that is 0, 1. So this is my equivalent of, 45.25 in decimal. It is equal to the binary value is 101101.01 in binary. The same value we are going to apply the same rule for the decimal to octal number. Here you can see that one example is given. Now you can follow the same thing, that is the decimal number 378.93 we need to change it into octal. So what I have done, the I am dividing, this is the integer portion and this is the fraction portion. Integer, now we are dividing by 8 and here we are keeping the quotient and here we are keeping the remainder. Here also same thing, in the fraction we need to multiply by its base and keeping the portion only the keeping only the portion of the integer portion, and we are getting like this. So this is the number of decimal to octal conversion. So integer portion is calculated like this way, and the same manner as I showed for the binary, the same manner octal number is calculated, that the fraction portion is calculated in the octal system. So what is the equivalent value? 378.93 of decimal number is equivalent to 574.7341 octal. The next here, the then decimal to hexadecimal. Decimal to hexadecimal, what is the base? Base value is 16. So that's why here I have taken one decimal number, that is 2598.675. This is my decimal number. Now I am going to change it in hexadecimal. So again I am dividing, this is the integer portion and this is the fraction portion. Integer portion is divided by continuous by the number system base. What is the number hexadecimal number system? The base is 16. So continuously I am dividing the quotient by 16 and I am keep on writing the remainder here. Here what? Hexadecimal portion, that is the fraction portion, is continuously multiplied by 16 because of the base is 16 and we are getting here the values of the integer. So according to this, the value is equivalent for this hexadecimal is A26.ACCCC. This is the hexadecimal equivalent. Now I am giving a very brief idea, that is how to converting the different number system, decimal to different other number system to decimal number system. So here the unnecessary, if I am going to do more, so that video becomes very long. So next class I am going to tell you about the other, the conversion between binary to other number system and its arithmetic. Thank you. And for any doubt, you can call me anytime.